Let's go ahead and get started. My name is Elisa Frias. I'm a teacher at Lancaster High School, and I'm going to be the host for our engineering panel this morning. I have a student with me, Brian Eaton. He's going to be helping me out with managing the Q&A. Attendees, I see that there are 44 of you. Thank you. Those would be students. Thank you for being here and for your interest in engineering, and welcome. I hope that this is a useful time for you to hear from some industry professionals. Brian is going to be helping me out. Brian Eaton is going to be helping me out with monitoring the Q&A. So I don't believe you'll be able to enter anything in a chat or anything like that, but if you have questions for our panelists, please make sure you drop that in the Q&A and Brian will attend to that. Let me go ahead and introduce our panelists. First, we have Brody Barton from Lockheed Martin Aeronautics. Brody is a manufacturing engineer who works with 3D printing. Brody says, I love being social and focusing on continuous growth. Welcome, Brody. Panelists, as I introduce you, if there's anything I'm missing or anything I get wrong, please feel free to just correct me. So let me know. Next up, we have Scott E. Ostrom from Virgin Galactic. Scott is a director of spaceships operations engineering and has spent the past 11 years preparing Eve for commercial service, as well as designing, building, and flight testing Unity in preparation for commercial service. Welcome, Scott. Thank you for being with us today. And finally, we have Mauricio Rivas of NASA. Mauricio is a NASA Advanced Air Mobility Project Associate Project Manager. That is a mouthful, that's a long title. As an engineer and project manager for over 30 years at NASA, Mauricio has had the fortune to support multiple aeronautics and science research projects. Welcome, Mauricio. Thank you for being with us this morning. Thank you to all our industry panelists for giving up your professional time to support our youth who are interested in the engineering career path. So what I'm going to do is I'm just going to ask some questions, and then I'm going to let our panelists decide, who's eager to answer this question. We may not have time for every panelist to answer every question, but I'm sure that we'll get a breadth of information here. All right, just one moment here. Okay, so the first question is, what was your career path to get you where you are? If I could have a volunteer from one of our panelists to answer that question, that would be helpful. Again, the question is, what was your career path to get you where you are?
I can volunteer to take that if you want.
Either one of us.
All right, let's
go ahead.
Scott, and then we'll hear from Mauricio.
Okay. Yeah, thanks, Elisa. And I can't see the students, but I'm excited to be talking to everybody. I think you said there's like 50, so that's awesome. So yeah, my career path has been, for the most part, aerospace. I studied mechanical and aerospace engineering for undergraduate. I went to Princeton, and then I did go and get a master's in engineering. But for the companies I've worked for, they've all been aerospace. I started with McDonnell Douglas and then worked for Boeing. At that point, I was kind of taking an interest in composite materials. So I took a job with a company in Oklahoma that specializes in composite design and manufacturing of aerospace products called Nordam. And then about 11 years ago, I came to Virgin Galactic, and most people have probably heard of Virgin Galactic, and we're building spaceships and flight testing spaceships to develop a commercial business of taking passengers up to space. So that's been my career path. I've focused more on probably the design and integration of systems with respect to the companies that I've worked at. So it's kind of my story, and I'm happy to answer any questions.
Thank you. Mauricio.
Okay, so my career path, beginning with high school, when I was in high school, I tried to focus on taking as much of the math and science curriculum that my high school offered. And to add to that, I also took college courses when I was in high school, just to make sure I could get as much of the science and math courses that I could. So once I got into college, I felt like I was a little better prepared, at least to start off. It was still a challenge going through college and doing all the coursework, but I focused on an engineering degree in electrical engineering primarily. I also got business minor, business administration minor. And through my time in college, I wanted to make sure I found a job that might give me an idea of what an engineer would do, or see if I liked it, or and see if I could do the work. So ended up getting internships and co-ops. I worked for Occidental Petroleum, Walt Disney Imagineering, and also NASA. And eventually, after I graduated, I began working full time at NASA. And once there, I started looking at how to move up in the organization, or how to improve um, my own work performance, and how to better prepare for the work I was doing. And NASA is very proactive in helping their employees advance. Um, they open a lot of doors for me, a lot of opportunities to continue education. I got a master's degree, also in engineering, and focusing on the work that I was doing, systems integration at um, on research aircraft that we flew at NET, that we still fly. Um, and after that, I wanted to get more into the project management aspect of things. And NASA continued to open doors for me to get the training that I needed for that. I participated in a leadership development program in NASA headquarters, continued taking more courses that NASA provides. Also ended up teaching at Northridge for a year. I taught graduate level project management and systems engineering courses. Um, and eventually I became a project manager, and the projects that I managed became larger, and the responsibilities increased. And until recently, I had been a project manager, and now I'm more on the supervisory role, where I supervise other project managers that have different research projects that they're doing.
Great, thank you. Brody, would you like to answer that question? What was your career path to get you where you are?
Yeah, I would love to. Also, sorry, I don't have my camera on. I don't have a camera on my computer here, but still excited to be talking with you all and sharing with the students. I, as opposed to Mauricio and Scott, am pretty early in my career. I just graduated from college this last April, so I've only been in my actual position for about 6 months. But my career began before that. So throughout college, I had a major emphasis on getting relevant experience to my career path. And so I did a lot of internships and was a research assistant for some of my professors, and would highly recommend that for anyone that wants to go into engineering, because that is one way to get your foot forward and get your foot in the door at a lot of these companies in order to then be in a better position to get the job. A fun thing about my job is that I get to work with 3D printers, and so I get to make some pretty cool models and some displays and everything. And so that's kind of been my career path so far. Moving forward, I have a lot of places that I can go, but I'm liking where I'm at right now.
Excellent, thank you. So in all of your answers, there was mention of, the first things that you did to prepare yourself for this career path that you took. The math and science courses, the internships, etc. Could you talk a little bit more about that? What's the best piece of advice you would offer a high school student right now to prepare themselves and position themselves for the success that you've experienced? Let's go in backwards. Oh, that's fine. Mauricio, great.
Oh, okay. um, yeah, so what I focused on was on taking more of the math and science courses that were available to me. Like I said, that was important to me because I wanted to make sure that I could do that type of work, and once I got into college, that I could handle the college level work. And you know, at least for my experience, the college level work was considerably more difficult than high school. Um, and it may depend where you go to school, where you know how that is and who your peers are, but it's a good expectation that if you're going into engineering, there will be a lot of competition and the courses will be a lot more intense. There will be perhaps more work that you'll do, but it's very good training, not just for the work you're going to do, but I believe in life in general. Um, you know, one of the things that stuck out when I was in college, I was having a lot of trouble in some of my classes, my earlier years, and I felt like I gotta just move into a different major. You know, I could see my friends needing to do less homework, and I thought, why do I do this? One of the advices that I got from an advisor at school was um, that I should stick around, stick with it. All I needed to do was put in the work, and I could go through it. And the point that they made is that with an engineering degree, you open more doors. You can go back and do a lot of other things that you might not be able to do if you have a different degree. For example, if you have a history degree, you might not be able to get an engineering job later on. But vice versa is probably true. You could get a degree that doesn't require engineering, or you get a job that doesn't require engineering if you have an engineering degree. So it opens a lot more doors, and your options are broader once you're out of school to see what really fits you better as far as a career goes. So I think that's one of the advantages for an engineering degree, and focusing on the education you need for that degree is helpful.
Great, thank you so much. Our other panelists, again, the question is, what's the best piece of advice you could give to high school students to prepare and position themselves for success?
I'm happy to provide an answer. So yeah, the advice I would give, I would say I generally followed it. And kind of as Mario said, or Mauricio, I'm sorry. Obviously the coursework's important. You need to study the right, classes and subject matter. But what I would really recommend, and I think times have changed. This wasn't necessarily the case when I went to school in terms of the available projects and clubs you can participate in that are engineering related, where you're actually building products. We interview a lot at universities where there's robotic clubs, there's automobile clubs, there's aerospace clubs, where you're not just designing, building, you're designing, building, and testing these vehicles, but you're doing the engineering behind it. And so to me, it's the application of the engineering knowledge we're acquiring, and then being able to apply that to build something. And we had kind of limited opportunities when I was in school to do that, but I think universities today are much, much better. And so, but it is going to rely on, students taking the initiative to do that. It's not always required. So I would definitely recommend, even at the high school level, if like robotic clubs are available, to do that. So that's my best piece of advice. And it actually will set you up really well, because when we recruit, that's something we really look for, is that experience, actually hands-on and applying the engineering knowledge to building the product.
Yeah, I can jump in after that. So one piece of advice that I have is kind of has to do with projects and with applying what you are learning in school. There's kind of two ways to approach a project. You can approach it one through just kind of making assumptions of guessing on thicknesses or different things like that. Or you can apply what you are learning in school and do some of that math and analysis behind it. And the first way is obviously the easier way, but the second way gives you a much more top of the line end product and gives you much more learning throughout the project as well. So I would say following exactly what Scott and Mauricio said, make sure that you are jumping on those clubs and those projects to apply what you're learning, and then also kind of do them the right way, I guess, of actually doing the math and the analysis behind them as you learn how to do those things. Just begin to apply them as much as you can, even though that is the process that takes a little bit longer and a little bit more effort.
Great, thank you so much. These answers are so detailed, so full of information that if our students are taking notes, they can follow this advice. But our time is short this morning. So we do need to make sure that the students are able to get to their next workshop on time. All right, great. Thank you so much.
Thank you.
Thank you.
Thank you, Elise.